my wonderful IB2 students. Today we're just going to spend a little bit more talking about infinity limits and a little bit more about asymptotes because we haven't spent a lot of time on that, and I just want to make sure everybody's kind of on the same page. All right, so infinity limits. Use the left and right hand limits to help you. So for example, let's say that we're taking the limit as x approaches 3, that's where that dotted asymptote is, from the left-hand side. As you can see, the graph is going downward toward negative infinity, which is why we'll write negative infinity. Now, on the other hand, as you approach 3 from the right side, we're going up toward a positive infinity, or just infinity. And because those two infinities are not the same infinity, they're opposite directions, we're going to say our limit does not exist. Now, let's take a look at this one by contrast. So I made a mistake on this. So if you're looking at the notes, you want to change those little 3s to 2s for me? Thank you so much. All right, so again, we're going to look to the left first. So as we approach our dotted line, our asymptote, we're going up toward positive infinity, or just infinity. As we approach from the other side, we're also going toward infinity, which means that in this case, since those match, you can say they are the same. So that's a very visual way to do it. Now, let's talk about the stuff that's down here, more about asymptotes. So using asymptotes can help you find limits. Notice that in both of these cases, we had asymptotes, okay? Both of those. Now, let me just remind you that you always want to look at your graphing calculator to make your final decision. Now, first thing we want to do is, if you need to find a vertical asymptote or a hole algebraically, okay, you're going to set the denominator of the fraction equal to 0 and solve it. Holes will happen when you have the same factor in the numerator as you do in the denominator. Okay, so first thing is, let's find our vertical asymptotes, or holes in this case. So in this case, I would take my denominator, set it equal to 0, and it looks like I'm going to either have an asymptote or a hole at plus or minus 2. Just a reminder, if you square root both sides of an equation like we did here to get to here, because we square rooted the x and we square rooted the 4, you got to put the plus or minus. Now the thing is, I don't know if those are asymptotes or holes, so I'm going to do a little more investigating, and I'm going to factor my numerator. So let's see, that'll be 2. Oh, no, I need that one to be the plus and that to be the minus, okay? And down here on the bottom, I've got x minus 2, x plus 2. So right here where we have the matching denominator, that right there, that's going to produce a hole. So if I put just that piece equal to 0, I know that x equals 2 is a hole, and x equals negative 2 is an asymptote.
Good Friday afternoon, Centennial students and staff.
Who doesn't love some additional announcements?
For the instructions.
While we're waiting on that, you just go ahead and
the J Hall,
graph it.
PE Hall, and the portables. Please dismiss your students at this time. Again, if you are in the J Hall, PE Hall, or portables, please dismiss your students at this time. Thank you.
Okay, now I'm going to go look at my graph. Oh, my graph's all messed up. So remember that what we talked about, as soon as it's done, you do zoom 6, and that takes you back to normal graph. And as you can see, there's an asymptote right there at negative 2, and we can't see that other spot, but if we go to the table, we see that there is an error message at 2, which is where there's a hole. Okay, now let's go over to the second one. Now this one, there's no denominator, so we're just going to come over here and we're going to graph it. Now, just a reminder, cotangent is 1 over tangent of x. So when I go to type that, I'll be 1 divided by tangent of x. And then I'm going to go look at the, 1 divided by tangent of x. And I'm gonna hit graph. So just looking at this, and just kind of a reminder, cotangent can also be written as cosine over sine. You're looking for all the places on the unit circle where sine is 0. Now, if I'm just looking for it between, let's say, 0 and 2 pi, sine has a value of 0 at 0, and it also has one at pi.
At this time,
Wow, just
teachers
keeps going.
in the I hall, please dismiss your students. Again, teachers in the I hall, please dismiss your students at this time. Thank
So
you.
if I want to make a list of like every single combo of this, I would say 0 plus pi, and then I put a little k on there, where k equals 0, 1, 2, and that's going to give me all those beautiful little asymptotes. All right, so do I have any holes? No holes, just asymptotes. Okay, so your homework is out of the book. It's on page 88, 1 through 7, and 13 through 27 odd. If you have any questions, of course, send me an email and I will send you back solutions to whatever your problem is. Like I said, short notes today. It will take you a little longer to do your homework, but as you're going along, just let me know what you need help with.